Hello everyone. In this video, we are going to learn some safe refactoring techniques. How can we refactor code in a safe manner in a small step-by-step process? So there are different kind of refactoring depending on what you are trying to achieve. For example, one would be just migrating the old API to the new API, or like removing the deprecated API and using the new methods, or basically like renaming the class, or because of the requirement change, you need to change the existing design. On all of this refactoring, I would suggest personally to start with the simplest one, which is basically very underrated around developers, is that delete the code. So basically you need to find a code which is not being used and just sitting there. Just delete that code, because less code required less maintenance and it will have less cognitive load around the team that how that piece of code works there. I have seen a code base where there will be a lot of commented code there. I think this is pretty much straightforward, that since you are using a Git version control system, you can pretty much delete that code, and then if you need it, you can go back in the past and get the context of that code. And also with the help of IDE, you can pretty much find out the unused code and method and then start deleting it. To delete a code, there are also two types of ways you can delete it. First is like using a linter or the IDE. In order to understand that the code has been used or not, find the usage of that code and delete it. For example, if I go to the home screen, we will try to find a code which has not been used. And in IntelliJ, there is a handy tool called F2, which is basically takes you to the first error in the file. And if you keep pressing it again, it will take you to the next one. And if there is no error there, it will take you to the lint. Basically, lint checks are static analysis tool built in Dart and Flutter plugin and many other frameworks. Is basically identify the code base based on that check. So for example, if I press F2 here, it will take me to this boolean where it's going in a gray color. Thing is, the static analysis checker here is checking that this variable has been declared but not has been used anywhere. What we can do is we can pretty much remove it like this. Now we have deleted the unused code here. In some cases, just don't blindly follow the tool. You just need to aware that what are the contexts in that lint, and if the tool does the right thing, then it's okay. But if not, then please do that changes manually. Now the second option is like without using the tool, how to delete a code. In that, you need to be more context aware or framework or language aware that how things has been working. For example, we have a add task here navigation, which is basically if you navigate to this, it will open up the add task screen. Now, if we want to check a usage of this, it's not easy to find because it's a string and the IDE cannot find that whether this add task has been used or not. But since we are aware of that this is a Flutter app and we have defined a route, so we would be expecting somewhere that there would be some navigator dot push name route, which basically would be pushing this route. Now, since we know how it's supposed to work in the context of Flutter and routing mechanism, we can easily find that whether this has been used or not. You can just basically search for this push name, just Control C, push name, and we'll see that we have a lot of push name here. And we'll just search if the add task has been called, and you can see that I don't find any route where the push name with add task has been called. Or I can just search that at how many places add task with the route has been called. So it's just the only one place here, which is the material app. Or I can just search the add task direct string if it had been used in anywhere like this. So you can see that it's being used on here, but there is no direct string use here at task, which basically navigate your route. So this way you can test it with multiple string and combination to see if that is being used anywhere or not. So I find there is no usage there. So what I'll do is I'll just remove this code here. So now I have removed the code which has not been used throughout the app. There might be also some code in your code base where you have a if else condition and there might be some static value coming from a top. and then you realize that it would never fall into a else condition. So you just remove that else condition or if condition. So now since we have a deleted code, let's run our test to see if everything is fine and nothing is broken. So we'll run our test here and everything is passing, nothing is broken yet. Now, how do we do a safe refactoring? I'll show some techniques with the small techniques here, which you can basically use into bigger apps and bigger method and classes. For example, in our home screen, if we go here, we have an empty view here, basically, which is this method, which basically show an empty message in the center of the app. And if you see, it's being used on home and task completed classes. In Flutter, basically, this is not a recommended way on how to create a widget, because if you use a function in order to build a widget, this will rebuild the widget every time the build method is called. So we are not leveraging Flutter framework algorithm to reuse this widget and not build it every time. So how can we migrate this function to a widget? Like most of them, what we'll do is copy this and go to empty view here and just paste it here again twice, and then get that optimization on Flutter side. But my intention here is that currently it's been used only on 2 places. It would be easy to do, but in most cases it would be used more than 15 or 20 times in your code base, and it's not a good idea to go everywhere and make that change. So how do we do that in a safe manner? So first thing is that you need to extract this center into a separate widget, but you don't want to break this existing code. Now, instead of building this center here, we can extract that into widget first and return that widget directly from here. So now we want to extract this center into a widget. One thing you can do is basically create a manually stateless widget here, no task, and then move this center in the build here. But I won't recommend that if a tool is already doing that for you. In a Flutter Dart plugin, we already have that refactoring tool. So for example, I need to select a widget, go to refactor and just extract Flutter widget. And I'll just give this name no task found. I'll just rename it to found. Now it extracted all the boilerplate code and did everything which we are going to do it manually. But you see the problem here that we need an empty message to be shown it here, which is coming from home and task complete, and both are different messages. Now here is the thing, once you understand the tool, how it works, you can pretty much hack it around for your need. For example, let me just revert this change. And if you pay close attention to the tool what it does is basically copy all this code and put it into the new widget. And it doesn't have any context about this empty message. So we can extract a variable here. So let's say I'll just use command option V and I'll give this variable called a name message. Now, since this is a function inside it, when I refactor it, it's taking a variables from somewhere. Now what I'll use the same technique here, copy this and then refactoring into a widget, and I'll call this no task found, and I'll just refactoring it. Now what it does, it took that message as a variable, did the required keyword and then pass it here, and did all the boilerplate code for me. And now what I can do is, instead of this message, I can just inline it like this. So basically it will take the message from here and pass it on here. So with using that tool, we are able to extract that here in a very safe manner. And if we just want to verify that if this change has broken something or not, we'll just run our test. Now all test passes. Now since we want to replace this empty view with our widget, I see there are 2 places where it has been used. So instead of going manually changing it there, I can use Control T here, which gives you an inline refactoring, which take this method and inline it wherever it has been used. Basically, because we have just one line here, it's like a delegating method. So it will inline this delegating method with this widget. I can just go here and I'll just do it inline, and it will ask inline or reference and remove the method or leave the method. But I just want to remove it. So I'll just keep that as a check and I'll do a refactor. Now that method is gone and it has been replaced with this widget. So if I go and check out this usage, I'll found that this has been replaced, if you check the changes here, with an empty view with no task found and the message which we pass it here. So this is how we have safely moved from one method to a widget without doing much of a manual work around every code base. So this has been done automatically for us by the tool. And now, since the tool was smart enough to understand that it is a const, what we can do is wherever it had been used, we can use the const here. And if I come here, I can make it const. So advantage of using const here is that this widget will be only created once, and whenever const task found is being used, it will reuse this widget. So it gives us some performance enhancement on a Flutter side, and all these things has been done out of the box in the Flutter framework. So you don't have to worry much about it. Currently it has only 2 usage, so it won't give that much performance boost, but imagine that if you are using this across 15 or 20 files with around 100 or 200 usage, it will be really helpful if you can migrate that into a widget and using a const there. Now, since we have migrated into a widget, it's always a good practice to run the test again. So I'll just do that and see if nothing is broken. So yeah, everything is passed. Since this is a small widget, I mean, the good thing about this declarative programming is that you can convert us into a small part of component or a widget, and then you can test that individually. So I can just load that no task found in my test and see if the message has been shown with the purple color or not. So it's also improved the testability because you are just independently creating a small component. And sometimes if you come across a widget which is very hard to test, you can use this refactoring technique to extract into a separate widget which does not have that much dependency, and just write a test for that widget. I'll just show you another example on how we can safely refactor it even we don't have a test for it. For example, the show snack bar method here. We don't have a test around it, but still we can use this technique which we used in the previous. For example, here the show snack bar is being deprecated, and if you go into detail, it shows that it now uses scaffold manager dot show snack bar. Now we don't want to use this API anymore since it's deprecated, but we want to replace it with the new one. And we also don't want to break existing code. As I said before, you can go to the show snack bar and make change to all those classes manually, but that would be really error prone. I think first thing is, like show snack bar, you need to figure out how this API works. So for example, I'll just go to here, I'll just use a scaffold manager, and I don't find this show snack bar method because it required a context, and then it can have this show snack bar method and show this snack bar. So I need to do some manual refactoring here. So I'll just copy this and I'll just paste it here, snack bar 2, and instead of this, I'll just use a build context. Just keep in mind that I'm keeping this both method signature same. It's just that I have changed this name to snack bar 2. So why I did it, you will know in a few minutes. So now since this is the same code we have here, and we don't have a context here, but since we are using a global key, we can get that context. So what we'll do here is I'll just use the snack bar 2 here, and I'll use scaffold dot current context message plus the material color which is coming from the optional material color which is coming from snack bar here. Now since we have one method which is basically delegating to this, as we did earlier, we can just basically inline it. I can just go to the show snack bar. I'll just do an inline all reference and remove method, and it will do the refactoring here. And if I check now, it being replaced by snack bar 2, and it automatically taking the scaffold home state with current context. So it has been automatically done for me, and I don't need to worry about breaking anywhere. So if I see it being used everywhere, and now basically you can use renaming factoring, and you can use show snack bar 2. So this is how we are safely able to migrate it to a new snack bar without breaking the code. So if I go to the snack bar, I can see that it's being used scaffold home state. And for safety sake, if I have not break something else, I'll just run my test to see if I have not broken anything. So this is how basically whenever you make a refactoring change, you run your test to verify if you have not broken anything. So this is how the test work as a safety net. And if you have broken anything, the test will start to fail. Now, if you want to go one step further, basically you can see that this scaffold home state basically is passing current context, and you can directly, instead of having this, you can pretty much replace with this context coming from here. There's a shortcut in IntelliJ called Control G, which basically select the same selection here like this. So there are two selection, and I'll just replace it with context, which is coming from here, and then I'll just check the usage of it where it has been used. So it's been now only used as a key here, but since I'm using the build context, I don't need that here anymore. So I'll just remove it, and I'll just see that it's turned into a gray because it's not been used anymore, and I'll just remove the code. So to conclude that, I think in my experience, I have seen most developer who just use this refactoring tool to just rename class or moving method. And if you're planning to improve an existing design, use this refactoring technique step by step, which is more safer compared to just moving a bunch of code all at once. And then keep running the test again and again to verify that you have not broken anything. And the crucial step here is you need to identify the smallest step you can take to move something without breaking anything. And you don't have to worry about this. Even if something goes wrong, you can pretty much run your test and verify that everything is working as expected. So if you find a step which breaks your code, then you can pretty much revert it back and then try to find another way to, safely do it.
So yeah, that's it. And thank you for watching this video. And in the next video, we'll discuss one of the most favorite topic in Flutter on how to choose a state management solution. So stay tuned and see you.
So if you like this video, then please like, share, and subscribe. Thank you.